Alright, day 2 of linear transformations. Today we're going to talk about multiple transformations. Alright, so let's review what we've talked about thus far. We talked about vertical translation, that is to move up or down. And that's a change in the y-intercept. Okay, so a graph shifts up or down by that many units. Okay, we're going from the parent function, which has a y-intercept at 0, 0, passes through the origin. Okay, and we're going to move up or down. We're going to translate up or down based on my y-intercept. Vertical stretch and vertical compression is a change in the slope. Vertical stretch by a factor of m, okay, where the graph is steeper, and a vertical compression by a factor of m, where the graph is flatter. Okay, so the bigger the number, it's a vertical stretch. The smaller the number, vertical compression. Reflection over the x-axis is when I have a negative of the entire function. So the graph reflects over the x-axis when I have a negative of the function. When I have a negative of the function. Alright, so let's look at some examples. Okay, so we're going to take our parent function, which is here in the dotted line, and we're going to transform that parent function. So my new function is going to be y equals 2x. So let's look at what changed from my original function to my new function. Well, this has a slope of 1. This has a slope of 2. So my slope got bigger. Okay, let's go back up here. When I change my slope, it's either a vertical stretch or a compression. So this is going to be a bigger slope. So this would be a vertical stretch by a factor of 2. Okay, and what that looks like, the y-intercept is still at 0, right? We could say plus 0 here. So the y-intercept is still at 0, 0. To get my next point, I'm going to go slope, which is 2 over 1. So I'm going to go up 2 over 1, up 2 over 1. And my graph looks like this. So we can see that my new graph is steeper than my original graph. That's why it's a vertical stretch. Going to the second one. Again, we're basing it off of our parent function, which has a y-intercept at 0. So I can see here that my b's changed. Okay, and if we go back to our notes, if the b changes, it's a vertical translation. So we're either moving up or down. We moved down 3. We went from 0 to a new y-intercept at negative 3. So my graph shifted down 3 units. Vertical translation down 3 units. If we were to graph that, it would look like this. Now, big important point here. Notice those two lines are parallel, right? They have the same slope. They both have a slope of 1. So those lines are parallel. All we did was move that graph down. These are not parallel lines. They don't have the same slope. Y equals negative x. Okay, y equals negative x. Alright, so let's graph this. Right, so I still have an origin. I still have my y-intercept at the origin. Okay, because this is plus 0. But the difference is we have a slope of negative 1 over 1. So down 1 over 1. And in this case, it's reflected across the x-axis. And you can say it's also reflected across the y-axis. Okay, because my slope, the sign of the slope changed, so it's a reflection across the y-axis, and the y-intercept is still at 0, 0. Same thing. Alright, so let's look at our next example. We have y equals x, and then we changed it to y equals 2/3 x. So this has a slope of 1. This has a slope of 2/3. So my slope got smaller. Again, when your slope gets smaller, it's a vertical compression. Slope gets smaller, it's a vertical compression by a factor of 2/3. So let's graph this right here. Again, the y-intercept is at the origin. We're going to go down, up 2 over 3, up 2 over 3, up 2 over 3. We can go backwards. We can go down 2 over 3, down 2 over 3. And you can see that your graph is flatter than the original parent function. Alright, so let's look at what this looks like. okay, if we have multiple transformations, right? So we're basing it off of y equals x, okay, and I see here that I changed my slope and I changed my y-intercept. All right, so what happened? We shifted it up 3 units because the y-intercept changed to a positive 3. It went from 0 to positive 3. And it's a vertical stretch by a factor of 2 because it went from a slope of 1 to a slope of 2. So to graph this, we have a y-intercept at positive 3. We're going to go up 2 over 1. So there's your new line. So the graph shifted up 3 units. Oops. And was vertically stretched by a factor of 2. All right. Again, okay, two transformations. Holy smokes! 2 transformations here. First off, the sign of my slope changed and the number changed of my slope. So what happened, right? We reflected across the y-axis and stretched by a factor of 2. Alright, so let's graph this. We still have the origin. For my y-intercept, we're going to go down 2 over 1. So down 2 over 1, down 2 over 1, up 2 over 1, up 2 over 1. My graph looks like this. Okay, again, this, okay, which controls that, and then the 2 right here are 2 different transformations, right? The 2 is a vertical stretch because it went from a slope of 1 to a slope of 2. We're basing off the parent function, which is y equals x. And then the negative is a separate transformation. Negative is a separate transformation. It's a reflection. All right, let's look at the last one here. So I know I have 2 transformations here. The slope changed and the y-intercept changed because we're basing it off of y equals x. So this would be plus 0. We went to a negative 2. So we know right now that we translated down 2 units because we went from a y-intercept of 0 to now a y-intercept at negative 2. So we went down 2 units. Now this is a different transformation. We changed the slope. The slope was a positive 1. It went to a positive 1/2. So that is a vertical compression because my slope got smaller. So a vertical compression by a factor of 1/2. So let's graph this. We have a positive 1/2 for my slope. So from my y-intercept, we're going to go up 1 over 2. Bam, up 1 over 2. Bop, up 1 over 2. Bada bing. Okay, and my graph looks like this. So identify the transformations just given the equation or the description, right? So let's look at our transformations here. So y equals x, right? So we have 1 transformation, we have 2 transformations, and then we have 3 transformations. So what happened? Okay, so from the function y equals x, we reflected based on this negative for my slope. So reflected over the y-axis. We had a vertical compression by a factor of 1/2, sorry, 2/3, and then we shifted it down 1 unit. Alright, let's write the equation for number 2. So a line with a slope of 3 passing through the point negative 1, 2. So what are we given? We're given a point and a slope. We need to plug it into point slope form. Y minus y1 equals m, x minus x1. So plug in my slope for m, plug in x1 and y1. So y minus 2 equals 3, x minus negative 1. Y minus 2 equals 3, x plus 1. So let's solve for y. Y minus 2 equals 3x plus 3. I distribute my slope. And then we add 2 to both sides. Y equals 3x plus 5. So what happened from the function y equals x to the function y equals 3x plus 5? We see my first transformation here, a change in the y-intercept. The second transformation is a change in the slope. So this is going to shift it up 5 units. And this is going to stretch by a factor of 3. All right, you're doing number 3 and number 4.